What are the technical capabilities of a quantum orchestrator? It's going to handle low-level device management. And what is a low-level device can even depend on the particular application. So whether that is in the lowest level of this diagram, beam splitters, entangled photon source, polarizing beam splitter, or maybe your low-level device is a network appliance, such as an Aliro device, providing quantum key distribution, for example. One of the most important technical capabilities of the quantum network orchestrator is abstracting the actual configuration and management protocols. So I mentioned earlier, without an orchestrator, you might be stuck running around with a laptop, plugging into different types of ports. Frankly, you're lucky if they all have a USB port or a network port. What we've seen in the wild is, oh, this one has a DB9 serial port, this one has an RS-232 serial port, but it's a proprietary plug that only this company sells. This one's VXI11, this one's RS-485, this one is NetConf, this one is Visa. You probably haven't even heard of all these protocols. And that is actually the point, right? Is that we've heard of the protocols and written drivers into a vendor-agnostic orchestrator so that the network user and the network operator do not have to know what these things are or how they work. Resource abstraction. This gets us up to another higher level of abstraction, not just that we can use an orchestrator to configure a thing without worrying about what its management interface looks like, but maybe without knowing in particular what it is. Maybe instead of saying, hey, we need to access photon source number 13 in equipment room A, which is a quantum Acme model number 13, what we'd really like you to be able to do is just say, for my current application, I need an entangled photon source. And I need it to be at 1440 nanometers. And I need it to be at so many picowatts of output. And all of the selection should happen behind the hood, under the hood, right? Is, okay, what photon sources do we have available? Which of them are not in use? Which of them are currently actually turned on and available at this moment, as opposed to maybe they're on the network, but they're down for maintenance? Which of them have the characteristics that you need? Which of them are routable to the other devices that you've called for in your setup? And routing, obviously in a classical network, we're all familiar with routers and switches that are going to read the packet header on the electrical information coming in over an electrical wire and use that to determine, okay, this packet needs to go out switch port number 36 to reach its destination. We don't have that with quantum information, and in fact, we can't have that with quantum information, right? If you are trying to communicate a state of quantum superposition over a fiber optic cable, and some device that is routing that signal makes an observation of the quantum state, then it's going to collapse the superposition, and that is going to defeat the entire purpose of why you were trying to communicate a quantum superposition state in the first place. So in quantum networking, we use optical cross-connects, setting sort of fixed routes between devices, but those routes can be provisioned dynamically by moving mirrors to actually route an optical signal from one port to another. And so I mentioned earlier not having to worry about, okay, this photon source is in equipment room A because I need the detector that's also in equipment room A. If there is an optical route available between these devices, then Quantum Network Orchestrator will be able to find that route, set those optical cross-connects and provision that for you, or generate an error and say, hey, you know, you said you wanted a 1440 nanometer source and you wanted a detector and you wanted a prepare module. I can't actually find all of those things available with optical routes between them. And that should happen for you instantly and without you having to know the underlying physical topology of the network. Error handling, we talked a minute ago about why is the thing at this particular moment not working. If something is not working, instead of going around to each device again with your laptop and your serial ports and whatever and testing it, the orchestrator is going to surface an error for you and say, hey, we have a problem in the Aliro's box number 13 is reporting an error condition. This is the error that it gave us. That's what you need to resolve. And alarms, so you can see in this diagram, we've got these graphs here, and we'll talk about that in a second. But of course, we all know that humans are kind of bad at staring at graphs and then reacting to changes in data that mostly don't happen, but are important when they do. Not only are we categorically as a species bad at it, it's really boring and we don't like it. Computers don't get bored and they're really good at it. And so an orchestrator should be able to monitor different telemetry from your network and actually generate alarms when something needs human attention.